So today I want us to just have a quick exam review of binomial distribution in part 1, and in part 2 we are going to look at geometric distribution. So for this part 1 video we'll look at binomial distribution, and I just want to give a quick brief review of what binomial distribution is. So for binomial distribution, questions on binomial distributions are: number one, discrete random variable. A binomial distribution must be a discrete random variable. And then secondly, binomial distribution looks at R successes. So let me just write that: out of n fixed number of attempts. N fixed number of attempts. Okay. So this is basically what binomial distribution gets to do. So binomial distribution should be a discrete random variable, and then it measures the probability of being successful R times out of a fixed n times number of trials. You will then realize that this is not the case when we talk about geometric distribution, but this video is not to talk about geometric distribution. Now, because it is binomial, the binomial coefficient plays a part. So you must be picking your binomial probability using a binomial distribution, the one that we looked at in pure mathematics 1, n choose R, the binomial coefficients. Then the P here talks about the probability of success, and then the Q here talks about the probability of failure. And if P is success, then it means failure, which we are calling P, should be 1 minus P. Because remember, all probabilities add up to 1. So if the success probability is P, then the failure probability, which we call 1 minus P, will be represented by Q. In other books, they say 1 minus P, simply because we know that success and failure must all add up to 1. Now, if you want to find the probability of a binomial distribution, okay, and you want to find how many times someone gets successful in a binomial distribution out of maybe n attempts, this is the formula we use, where this first part, n choose R. In other books, n choose R is just written as nr. So let's not get confused about that. This is the formula you need to know to find the probability that a particular random variable, which is following the binomial distribution, has R attempts which are successful out of the total number of attempts. All right, and then we also find the expectation of a binomial distribution simply by multiplying the number of total attempts times the probability of success. Then the variance is also found by number of total attempts times probability of success times the probability of failure. Those are key formulas that we actually just need to know. And in this video, I just want to quickly run through a few questions to just give us an idea of how to answer binomial distribution questions. Remember, for binomial distribution, you have fixed number of attempts and you are looking at R successes out of the fixed number of attempts. So let's look at question number 1. A fair coin is tossed 20 times. So you see n, this is fixed, times, and it lands heads. Okay, so we're now looking at a fair coin which is tossed 20 times and the number of times it lands heads. So number of times, that's our success. Success, it lands heads. Define a suitable distribution to model the number of times the coin lands heads up and justify your choice. So in this situation, how do we model this to be a binomial distribution? Then we must actually say, okay, let x be the number, okay, the number of heads we get out of 20 attempts. If we just say that it simply means we've turned this question in a binomial distribution, because remember, a binomial distribution looks at our successes out of a fixed number of attempts. So now x is talking about the number of successes out of 20 fixed attempts. If that be the case, then it means we are saying x is now a binomial distribution, which we normally write as this, where this is 20 and then the probability of success is 0.5. Now, for a binomial distribution, since this is just a review, a full video on the actual full lesson can be written. Remember, we've actually said in our notes, which I shared, that if x is binomial, it is represented as this, where this is n and that is p. N is the total number of attempts and p is the probability of success, which is just what I've written here. So if we are to find a model, we must say x is the number of heads we get out of 20 attempts, which means x is now a binomial distribution. That's about A. Then B says find the probability that the coin lands heads 15 times. Remember, let's go back to when we started. Binomial distribution looks at our successes out of n fixed attempts. So now here we've been told that there's 20 attempts. Our n is 20 and our R successes is 15, and they are saying find the probability that we are successful 15 times. So we know what the formula is. The formula is probability that x is 15 times. Remember, we defined that let x be the number of heads we get, is equal to n choose R, which is this part here. Our n is 20, choose R, which is 15, times the probability of success, which is 0.5, because when you have a coin, heads and tails, fair coin, they have 0.5 chances of occurring, and then R is the number of times we are successful, then times 1 minus P, which is Q. Our Q is actually 1 minus P, which is 0.5, and then we are doing this to the power of 20 minus 15, as the formula states, where I said Q is 1 minus P. So here, this is just using a calculator. N choose 20, choose 15. You just go on your calculator, 20, shift, choose 15. So 20, shift, choose 15 times 0.5 to the power of 15 times 0.5 to the power of, because 20 minus 15 is 5, to the power of 5. What we get there is 0.0148. So this is the probability that we have 15 heads out of 20. Okay, that's just about using that formula. Let's quickly look at the next question. The key are these three formulas that I've written here, and all these three are given in your formula sheet in your exam. You just need to know when to pick a binomial distribution. Then let's go and look at question number 2. And I just want to give a shout out to Save My Exam, a site that I use when making most of the revision questions. It's a very good site for you students. You can sign up and then you also pay for your subscription if you want a paid subscription or a limited subscription for a revision as well. Let's look at question number 2 here. There's maybe I may skip this one because we need to do more questions. Let's go maybe on number 3, which talks about expectation on any given day during a normal 5-day working week. So here they're giving you n being equal to 5, the total number of attempts. There is 60% chance that Yusuf catches a taxi. 60%. So we're looking at this guy catching a taxi. So this is our discrete random variable. Okay, so meaning the probability of catching a taxi is 0.6, since it's just given as a percentage. Meaning the probability of not catching a taxi is 0.4. Okay, find the expected number, which is the expectation. And you remember when we started, I said expectation is given as n times p. Find the expected number of days Yusuf will catch a taxi to work during a normal 5-day period. So expectation, as we've said, is equal to n, which is 5 times 0.6, which is just going to be 3 days. So 3 days, meaning Yusuf is expected to catch the taxi for 3 days. I picked this question because it's also asking us on expectation. Then B says find the probability that during the normal 5-day working, so here we know that N is 5. Yusuf never catches a taxi, meaning we are not successful at any point. Never means R, meaning the number of successes is 0. So we're just using that formula we started with here. This is the probability that Yusuf, the random variable, is not successful, which means 5 choose 0 times the probability P, which is 0.6 to the power of 0, times Q, which is 0.4 to the power of 5 minus 0. And if we do our math here, we just put on our calculator 5, shift, choose 0 times 0.6 power 0 times 0.4 to the power of 5. What we get here is 0.01024. So this is the probability that Yusuf never catches a taxi. So again, it's just direct application of the formulas that we have. Then find the probability that during a normal 5-day working week, Yusuf catches a taxi at the most once at the most. So meaning once at the most means that's the maximum. So meaning we are saying Yusuf should catch the car in actually one or less, because they say at most once. So meaning Yusuf should never catch the taxi more than once. Now, not more than once means that you are either one or less. Now, this means the probability that x is equal to 0 plus the probability that x is equal to 1, because you can either not catch the taxi or just catch it once. Okay, so the probability that x is equal to 0, if you are just, okay, is this one here. So I'll just keep that one there, and I'll just calculate the probability of x equals to 1, then add it to this answer here. So we're just going to work out the probability that Yusuf catches the taxi once, which is 5 choose 1 times 0.61 times 0.4, 5 minus 1, which is 4. And if I work out that, I'm going to do 5, shift, choose 1 times 0.6 times 0.4 to the power of 4, which then gives me 0.0768. Remember, this is for x1, but we need to add 0 for x equals to 0, which is 0.01024. So if we add this plus 0.01024, that gives me the answer of 0.08704. So this is the probability that Yusuf catches the taxi at most one time. Okay, so let us look at another question that we may find that may be interesting on binomial distribution. There is lots of questions on this workbook that I made using Save My Exam, and let me pick another question and see how we can answer that. Now, I found this part of a question that is very nice. The random variable here is a binomial distribution. Remember, we said if x is a binomial distribution, it should be written as NP, where n is actually the fixed number of attempts and p is the probability of success. So if you look at this, they are saying y is a binomial distribution variable, is following binomial distribution, where n is known and p is that. So we already know that p is 0.4. And at the beginning, we did say expectation is found by multiplying n times p. Now here they are saying, given that expectation of y is 12, find the value of n. So we know that the expectation of y should be equal to n times p. And then the expectation is given here as 12. We don't know what n is, but we are given the probability of success. So if this is just basic algebra, n times 0.4 gives me 0.4n equals to 12. I divide by 0.4, I divide by 0.4, and then I find that my n is actually 12 divided by 0.4, which gives me 30. So it means this binomial distribution has a fixed number of attempts, which is equal to 30. Then they say find the probability that this person is successful in more than 8 times but less than 12 times. So if you look at this, you can answer this in different ways. So they are saying find the probability that this person is successful more than 8 times but less than 12 times. So this is simply the probability that x, or not x, I'm sorry, I'm used to x. This is just the probability that y is equal to 9 plus a probability that y is equal to 10 plus a probability that y is equal to what? 11. It cannot go up to 12 because I said less than 12. So now here, it's just a calculator. Probability that y is equal to 9. It simply means 30, choose 9, times probability of success 0.4 to the power of 9 times, sorry, not 0.4, 0.6, yeah, 0.4, because that's a probability of success that we are given there. So 0.4 to the power of 9 times 0.6, because you know if you have p equals to 0.4, then your q is actually 0.6 because the two must add up to 1. So now this is 0.6, and then we do 30 minus 9, then plus 30, choose 10, times 0.4 to the power of 10 times 0.6 to the power of 30 minus 10 times 30, choose 11, times 0.4 power 11 times 0.6 to 30 minus 11. That's what we are doing here, and we're just going to use a calculator to actually find the answers to this. But you don't really need to be showing this. You can actually do 30 minus 9 on your own and then just say 0.6 raised to power 21, which is what I'm going to do here. So this is going to give me actually 21. So this is 0.6 to the power of 21. Then this is 0.6 to the power of 20. I'm hoping you now know where I'm getting these numbers. Then this is 0.6 to the power of 19. So I'm just now going to punch these on my calculator, that answer that I'm going to give me that. So 30, choose. So I'll just punch these on the calculator and give you the answer. You should be able to work it out. Okay, so the answer is 0.3370. So this is the answer to 3 significant figures. So it was as you understanding that they are talking about y is greater than 8, meaning 9. They are not decimals because these are discrete random variables. If you remember when we looked at discrete random variables, they've got not decimals. So if it's greater than 8, it means 9, 10, 11. Less than 12 means start from 11 going down. Greater than 8 means start from 9 going up. So that's the answer for that question. So now there is D part 2. So this is D part 1 that we did. D part 2, I'm just going to do it here. They are asking us to find the variance of this distribution here. Remember we said variance, okay, of y in this case is equal to npq. So our n is 30 times probability of success times the probability of not being successful. So 30 times 0.4 times 0.6, we get this as 7.2. So that's our variance. If they ask for standard deviation, we would have just done the square root of 7.2. So that's that question. I don't think there are other questions on binomial distribution that need us to maybe do I don't know. I don't think so. Let's maybe a fair dice is rolled 24 times and the number of times it lands on a 4 is recorded. Define a suitable distribution to model the. So here, you know, whenever you're given fixed, so n is fixed 24. Just trying to look at number 9 here, and we are looking at landing a 4, a fair dice. A dice has 1 to 6, and since it's fair, it means the probability of actually getting a 4 should be equal to 1 out of 6. I don't know where the issue is with my marker. So let's yeah. Okay, let's look at number 9 here. They've given us a fair 6-sided die. So here we are given a die which is being rolled. How many times are they rolling this dice? Okay, so we are just going to see if we can be successful with this question. These questions are mostly the same. So here, n is equal to 24. Okay, they've given us that, so I'm just going to make sure I've got that here. Okay, so n is equal to 24, and then we've got a fair 6-sided die, meaning to get a 4, the probability of getting a 4 is actually 1 out of 6. Meaning, if we are looking at getting a 4, meaning the probability of success is actually 1 out of 6. Meaning the probability of failing is 5 out of 6. Define a suitable distribution. This is similar to the first question. We can just say, let x be the number of times we roll a 4 out of what? Out of 24 attempts. And let each row be independent of the other. Be independent of the other. That would then imply that x is following a binomial distribution with the total number of rows 24 and the probability of success being 1 out of 6. This is how you get the first 2 marks. Define the random variable that you're looking for. We are saying let x be the number of times we roll a 4. Remember, binomial distribution looks at the number of successes you get out of a fixed number of attempts. That's why we are saying success is 4, rolled in a 4, and then we look at x being a binomial thing, which is the number of times we roll a 4. So that's the answer to that one. Find the probability that the dice lands on a 4 times. So we've got n being equal to 24, and then we've got now our x being equal to 4, meaning we are successful 4 times. This is a basic binomial distribution. So what we know is the probability that our x is coming out as 4 should be equal to, out of 24, we are doing 24 choose 4 times the probability of success, which is 1 out of 6 to the power of 4, times the probability of failure, which is 5 out of 6 to the power of 20. I'm sure you know how I'm doing 20. It's 20 minus 4. 24 minus 4. So here we are just using our calculator. 24 shift choose 4 times 1 over 6 to the power of 4 times 5 over 6. So I'm just putting this on the calculator and then just punching the numbers as they come. So we should all be able to do that. I don't think there should be issues there. So we just put that on the calculator and then see what we are going to have. This is power 20. So the answer that I'm getting is 0.214. That's the answer to that question there. Just basic binomial distribution. I don't know if there was anything. So that's everything about binomial. 45 all about 1. So just the language. At most means that's the maximum number of times. At least means that's the minimum number of times such language. So watch out the part 2 where we look at geometric distribution. Like you can see, most of the questions I'm skipping here are geometric. But binomial, that's everything we need to know. Thank you very much. Thank you.